Today's debate, will it run? This is a 2002 Isuzu Trooper. I bought it as a beater because I needed to get places, and it helped me to get places for a little while. After that, I picked up the electric Mustang, and then subsequently had to take it back, which is a bummer, but not altogether unexpected. Battery is sending electrons very rapidly and at a large volume to the starter. The starter is a kind of motor that is high torque, and it turns the flywheel that starts the engine. Are there ways to start the engine without the battery? Yes, but that's not plan A. Plan 1 is put the battery in and see what happens. When you connect the car battery, positive first, then negative. Why is that? Because the electrons come out of the negative lead. Big fat nothing. But that's okay. I had a feeling that battery was done. And we can actually check too. Let's go get the multimeter. Yeah, 2.5 volts ain't gonna cut it. When you deconnect the battery, you disconnect the negative one first. Why? Because the electrons are coming through this wire. So the first thing we want to do is stop that from happening. Second option. Well, we got connection, but we're not getting any start. Yeah, 12 volts. All right, let's get under it. Let's unplug everything. Part of me was hoping it would just kind of start, but you know, it's not really the world that we find ourselves in, right? Hey guys. If it wasn't so tight down here, this would be a great opportunity to talk about how cars work, but right now we're underneath the car. The car is supported on jack stand, and that is the starter. The starter is a motor attached to a solenoid. The solenoid engages the motor with an electrical signal from the battery. The solenoid motor, or the starter motor, spins, and it turns the big flywheel that cranks the engine. When the engine cranks, it's drawing fuel and air and everything, and it's beginning to start the process of igniting and internal combustion, all that good stuff. So, I can hear the solenoid clicking, which is, if you can't hardly tell, I know it's hard, there's two cylinders attached to each other with a bunch of wire, right? You see that? The big one is the starter motor, the small one is the solenoid. The solenoid engages the starter motor. It's all about following the electrons. So let's reconnect the battery, and I'm going to measure the voltage getting to the solenoid to make sure the voltage is getting there, because if it is, then that means the starter motor's bad. I have another one, but I don't know if it's the same size, but we'll cross that bridge later. Now, hello everybody. Now, if I connect, I'm trying to get you to see me. If I connect the positive lead to the starter and the negative lead to the engine block, which is ground, I know we haven't talked much about ground, but ground is basically where everything in the car, everything in the DC circuit goes back to ground at a certain point. The cement is cold down here. All right, so I got to connect this up here. Big fat nothing. Big fat nothing up here. Well, let's start with continuity. How about? Can you hear that? Getting continuity. Let's check for voltage. I need a clean ground. I'm getting 12 volts to this solenoid. I might just need to hit it with a hammer. Hold on. Hold, please. Alright, so let's chat. So I've got electricity going into the, well, every place the electricity needs to go. Where does the electricity need to go? Everything in the electricity of the car needs to go through one of these two cables that are all attached to this sort of main lead right here. There are two sets of cables that go different places. One goes down here to the fuse box and one goes way down there to the starter. Okay, so this car has a starter relay. Okay, if we look at the fuse box diagram, we can see that right there. Starter, that's that gray relay right there. A relay is kind of switch, and so if we're getting electrons at the starter at all times, let me double check. So I've done everything I can to follow the electricity, and I've found that all the electricity appears to be going to the right places. However, when we go to crank the ignition, whenever we go to turn the key, everything stops, which tells me that something is shorting out somewhere. Could be a problem with the ignition switch, probably a problem with the ignition switch, but just to rule things out, I'm going to clean all of these contacts that are contacting the starter. The battery is safely unplugged. There is no electricity in this circuit anymore. I went and I had a snack while I pondered my next moves. I have some of my socket wrenches. Gotta try to figure out what we're dealing with here. Huh. Well, that looks awfully clean. Here we are back under the car again. The starter motor is kind of wedged up in here above this tank, which is all part of the engine. So I'm trying to figure out how to get this out. Alright, so I'm going to splice in some video here and there for this segment, but what we're figuring out is that the starter's bad. The starter motor solenoid is clicking, it's moving into place, but the motor is not turning, the motor is not functioning. It's not spinning. And therefore it's not starting. Okay. So I've been under here for the better part of 5 hours. There's the starter again, our old friend. I gotta try to get that out of there, and it's not easy. I've taken apart as much as I can. I've got my hand in there as much as I can. From what I can determine, that bolt right there is what's holding it in place. Online research suggests there are other bolts holding it in place, but I can't see them or locate them or even figure out where they're supposed to be. So my only course of action right now is to A, research, or B, remove that bolt. Removing that bolt is going to be a challenge because, as you can see, The starter case, the motor case, is so close to it I can't get a straight shaft socket wrench in there, so I'm gonna have to get an extender that's flexible and low profile. In the meantime, I'm gonna do some more research and see if I can't figure out some other solution, because I haven't been neglecting you. It's just there's not much to see. It's a lot of been me staring at this, trying to figure out what to do. As far as I can tell, we've tried everything except fixing or replacing the starter with a new one. I don't know what else to try, so that's what we're gonna do. However, it may be beneficial for us to take that out, if we're gonna take it out anyway, and then test it separately. We'll see. So all of that being shown, how does something like that happen? As far as I know, that truck started a few months ago. So I have one here. So this is a car's starter motor, just like the one that we were looking at the bottom on the floor, on the cold ground earlier in this video. But it works the same way. We have a solenoid which actuates this plunger. That plunger spits a gear out, and that gear can then begin the process of starting the engine. 3 pins. One is primary power from the battery. One is the connector. One is the signal from the ignition switch that, hey, it's time to start. And this one that's connected to the main body is the thing that starts the motor. It says, hey, time to start, time to go. So there are 3 outputs here. This one is main power, so this is power coming in. This one is a signal that it's getting from the key. Whenever you turn the key, it says, hey, it's time to get ready to start. And when it's time to get ready to start, what's happening is there's a toothed gear in here, and that toothed gear comes out, deploys, so that it can then enmesh with the big gear, and that big gear can then start the engine. If we were to feed battery voltage in here and turn the ignition switch, which is what we did, and nothing happened, what that's telling me is that power is not getting from here to there. So part of me wouldn't be able to sleep unless I went and figured that out. So I went out in the dark and I performed a voltage test, where I connected the hot 12-volt signal from the battery directly to the motor winding here, and nothing happened, which tells me that the motor is faulty. Electricity was getting there. There was a lot of sparks, but ultimately nothing spun. The starter is either seized, or some other thing is happening in there that we don't understand. And the only way that we're going to figure it out further is if we take it out and take a look at it at the bench. So that's probably what you're going to see next. Second verse, same as the first. I don't even know if you're going to be able to see this, but I finally, after hours and hours, found the other bolt that I have to take out. I managed to remove one of them, but the other one, you can't even see my hand. Okay, there it is. Back up here under this wire, there's a bolt. Nope, not that one. Okay, right on the other side of this, there's a bolt that I gotta get out. I think I got it. Or not. I don't know if I got anything. Hold please. Okay, here is the offending starter. let's take it inside to the bench. We'll bench test it, and then if that doesn't work, we'll get another one. It's about $78 part. Relatively common problem as far as I can tell. That was definitely one of the hardest things that I've done on a car so far in my experience. I don't have a ton of experience, but I do have some. Mostly thanks to that lump of scrap metal over there. But let's go check this out. Yeah, this seems to be a relatively common part. I know how to get another one, get one on eBay, remanufactured. You get it. But for the time being, let's go ahead and take it inside and test it, and we'll just leave let's leave our tools under there for now. Here we are back at the bench with our faulty starter that appears to be completely caked in gunk and grime and goo and everything else. Part of me has a desire to try to get this to start while it's on the bench. Part of me also just wants to kind of throw it away or set it aside, let's say, because it's a relatively high current part and it's a little bit dangerous, and if it's not going to work, there's a lot of different things that could go wrong. But I'm gonna have to go get the battery from the car for right now, and so let's be very careful. So everybody stay cool. Huh, it is starting. So perhaps it was just seized. Here you can see the gear that I was talking about a little bit ago. There it is right there. You can see it shining in the light right there. That gear comes out when the solenoid is activated and then spins when the motor is activated. And based on that test that we just did, my presumption is that either the weather or either something melted and sort of welded itself together to something else, which is why it wasn't starting. Which is why there was so much physical resistance, which is why it was shorting out all the other electrical. My secondary hypothesis is that there was some goo in here, or the weather, something about the weather had changed the physics or the arrangement of what was inside somehow. We have no way of knowing without taking it further apart. But either way, it works now. And if we put it back in and it doesn't work, that's a different problem. We're back here at the bench talking a little bit about car electrical systems. It is nighttime, so I'm talking somewhat softly. Luckily, most cars should have a fuse diagram for the ways that the fuses and relays in the cab electrical system work. This is the one for the 2002 Trooper. I also have here the relay. This is the starter relay. Starter relay is right there. That's the starter relay. What is a relay? A relay is a kind of switch. It's an electrically actuated switch that utilizes a coil. The coil, when powers run through it, creates a magnetic field. The magnetic field causes a very thin and therefore lightweight metal strip to go from one position to the other position because of the magnetism it's feeling. That action breaks one connection and actuates another connection. That's where there's 6 pins on here. These 2 pins are the coil, so these are what we're putting power across. When we put power across this, the connection from these 2 pins, 1 and 2, and these 2 pins, 1 and 2, switch. That's the switch. That's what I mean by it's a switch. And if we remove this screw, we can see the coil involved. Let's do that. Way down in there. So far down in there that I can barely see it, even at that angle. There's a little coil of wire. There's a little coil of wire down there. Trying to get the light to catch on it. There it is, way down in there. You can kind of see it, glinting off something. It's in there. That's telling me that these two pins are the pins that control the switching, and so we can test that. All right then. Here's our standard continuity test. Okay. Here's our relay. The relay should be connected via the two pins which we suspect is the coil pins. Thank you. Meanwhile, these two pins should also be connected, which they are. Meanwhile, these two pins, the remaining two pins, should not be connected. And they indeed are not. However, when I apply a voltage across the coil, we'll find the opposite to be true. Okay, our testing scenario is this. I have a battery right here. This battery has a 14.4 volt output, but right now it's outputting 10 volts, which is fine. That's all we need. And I've got the purple wire as positive and the black wire as negative. I have the purple wire connected to one end of our coil. And when I connect this other wire to the other side of the coil, we should hear it click. I'll be very quiet. That's the switch. Now, if I connect these quote-unquote permanently, we will find that these pins no longer have continuity, and these pins now do have continuity because the switch has been activated. It's been energized. By the way, don't forget, the power coming out of this battery we charged with the sun via a solar panel. Isn't that something? Let's change gears just for a skosh, pun intended, I guess, after the fact. I didn't know it when I said it, but I caught it afterwards. A car ignition switch that has a physical key normally has a number of positions that you can turn the key to. But for the sake of this example, we have off, we have on, and we have start. The key spends most of its time in the on position. Right here in the main, this is where the power is coming in. The power goes from main, which is coming from the battery at all times, is going to the key switch. The key switch is waiting for you to turn the car on. When you turn the key from off to on, this fuse, this circuit, this gets power, this is energized, and it sends power to the rest of the car to do the rest of the car's things, like turning on the air conditioner and the fuel pump, and tail lights, etc. One of the things it's doing is preparing this in power to the starter. It's waiting for you to instead turn the key to start. When you turn the key to start, it sends power to the starter solenoid actuates, and the motor comes on, which then subsequently starts the engine. Right? We want power to be able to get everywhere when it needs to, but we also want to make sure that the starter is not constantly under load because it will burn up. It's just not, it draws so much current that the battery, it's the only thing on the car that the battery needs that much amperage for. A car battery has a lot of amperage, has a lot of current that it can output. And the only thing on the car that really draws a ton of current is the starter. And so we don't want the starter to be energized at all times. We don't want the starter to be getting power at all times. That would be a bad idea. And so we want to be able to switch the power coming in through the starter so we can still keep going, do the rest of the things. But we can also turn it to get it to actuate the starter, which is we only need to do when we start the car. But we have to do that every time we start the car. That's why it's designed this way. So we can have the option of getting power to come through and also getting power to go to the starter when it needs to. So that combination of lessons just then indicates to me why I think the starter motor is bad. Because the relay's working, we just saw it working. And nothing appears to be amiss with the rest of the power system, and the key appears to be working because we can hear the click of the starter solenoid when we go to start it. So something's happening between the click of the solenoid and the motor turning on, which tells me that the motor is having trouble turning on. Why is the motor having trouble turning on? Well, it could be corrosion, which we managed to overcome on the bench, but with the rest of the stuff going on in the startup procedure, it's possible that it can't overcome the corrosion or the gunk or whatever is inside it when in an actual environment. Now, there is a possibility that even though this relay is working on the bench, it may not be working in the environment. And so replacing this is another option. Something I'm looking into. It will be cheaper, but actually not that much cheaper. This is about a $40 part, whereas the starter is like an $80 part. Anyway, we'll see. We'll see what's going on. So, that being said, will it run?